So thank you very much, Group, for joining us. We are so much delighted to have you today. And this is Google Thinking Developer Community Nairobi. And we were so much excited and to learn from you, especially for you being the expert and the developer of the Google Thinking API, Python API, which is so much scalable for us. Most of us here are thinking developers, and also we have a mix of individuals who are highly motivated to learn in the software development industry. So everybody here is highly interested in our topic and all our community work that we have been doing. We usually run all these activities uh, bi-monthly or even once per month. But we this time around we wanted to discuss to learn more about the scalable engine Python API because this compared to the JavaScript it has some limitations. So we were thinking of exploring in depth how the Earth engine API works and so that we can get to explore more in this area. So those are just a few I will give you an opportunity just to do a short introduction about yourself, then we can get that. Welcome, Prof. Qiusheng, and we really appreciate your presence with us. Thank you.
Thank you, Nicholas, for the introduction. I think there's somebody in the background speaking.
আমার আমার রেসিডেন্স পারমিট বলবেন রেসিডেন্স পারমিট হ্যাঁ রেসিডেন্স পারমিটের জন্য একটু দোয়া করতে বলবেন আমি তো তোমার ফোনে আমটা লিখে দিচ্ছি জানাইতেছি একটু দাঁড়ান আপু একটা মিনিট আমি ফোন ধরতেছি আপনাকে
Okay, I think let's get started. So this one we are going to sort out this.
Okay, let me share my screen.
Yep.
Let me share the window. Can you see my screen?
Yes, it's visible.
Okay.
Yes.
Thank you everyone for attending. I sent the link to the slides in the chat. You can access the slide if you want to. And so today I'm going to give introduction to GEEMap. You might have used Google Engine. You might have the JavaScript API. So I'm mostly going to focus on the Python API. I'm going to show you some of the features that you can utilize. And so lastly, I will have some additional resources. You're going to learn more about the package or some other open source project that I'm working on. And the right shows you on interactive web app that you can use to create time-lapse animations using Google Engine. You can check out the link. And so here, this is kind of the interface. You can just go to the URL and then can start creating animations using Google Engine, using any satellite you want. You can use Landsat, you can use Sentinel, all kind of time series data. As long as it's available on the Google Engine, you can create animation easily. And so here's a short animation. You can basically just go anywhere and then draw a rectangle, and then you can export it as an ROI, and then you can upload to the web app, or you can just upload something directly from a computer. Then you can select the bank combinations, date and time, and also some parameters. Then you just click one button, you'll be able to generate the time-lapse animations for any location around the globe. You can do that for anywhere. You can, like I said, you can use any satellite data, and you can download the animation as a GF on your computer. It makes it really easy. So behind the scenes, it's using Google Engine to do all the computation, and also use GEEMap to create the interactive web app, and also deploy on Hugging Face using free cloud computing resources. So here, show you some interesting animations. For example, the drawing of the RC, mining in Canada, coastal expansion in Dubai, and also the river dynamics in Peru, the one that I showed you earlier at the beginning. Deforestation in Brazil, landslide, and urban expansion in Las Vegas, in China, in Mexico. This one is in Nairobi, so you probably familiar. It's not very obvious because the urban growth is not as obvious as those in Las Vegas and Mexico, but you can still see some changes if you pay close attention, especially in the south side here, some new buildings, new residential, and also commercial area in the south side of the city. And you can also do environmental monitoring, for example, coastal erosion. And so those are mostly Landsat data, 30-meter resolution back to the 1980s. You can also create animation using any set of data. So this one shows you the temperature changes within 24 hours. So you can create these kind of things easily just with a couple lines of code using GEEMap. You can also do ocean temperature mapping, dynamics through a longer time scale, for example, by month, by week, or by day, whatever you want. You can also do vegetation monitoring. So this one shows you the phenology changes throughout the seasons in Africa, in China, or you can do it at a global scale. So you can see it's actually very, very interesting when you looking at from space at a longer time span. Besides low cost resolution data, but here we also have a lot of high temporal frequency data. For example, the NOAA GOES satellite geostationary observation environmental system that allows you to capture images of the Earth every, for example, 5 minutes. So this is very high temporal frequency, but the nice thing about this, you can capture those natural disasters that happens in a short time period, but very, very fast. For example, volcanic eruptions, and also wildfire, for example, on the right showing here. So besides capturing the images, it can also actually do some analysis to extract the wildfire boundaries. So the pink color on the right shows you basically the wildfire spreading. So you can not only do data capture, but you can also do data analytics built on top of the Google Engine platform. So under the hood, these are all using Google Engine and GEEMap. And since this is a Google developer meetup, so you probably already know use Google Engine. So I'm going to skip quickly to this. The idea is that we are right now mostly doing things in the cloud. We don't use desktop computing to do large scale because you just don't have the cloud computing resources. So Google Engine is one of those, probably the most popular cloud computing platform right now. It's free for research and education. So you can sign up account nowadays using your Gmail, and then you can start doing coding using the cloud computing platform. So these are some of the advantages why you want to use Google Engine. It's cloud-based. You just need a browser, and you can do large-scale data processing at a global or continental or national scale without downloading any type of data. And it has very user-friendly. It has a huge data catalog. So this is one of the biggest advantages of using Google Engine. It's already there. So the data has over 100 petabyte, 100,000 terabytes. So you can pretty much use any data available in the public domain. And it provides the Python and JavaScript API, and beneath it also has the REST API. And free for research education. On the right here shows you the publications that use Google Engine during the last couple of years. So you can clearly see the exponential growth during the last couple of years. It's going to continue to grow because it empowers researchers to actually do global scale studies very, very easily. So you can focus more on your mechanism, focus on more on answering scientific questions rather than having to manage the data. And so this is one of the simplest applications is to do, for example, cloud removal. So you might have done this. You can point to an entire image collection, then just do a median filter, and then you can quickly create cloud-free images like this. Just one line of code. And some of the images, for example, on Google's that you see, it probably might have been processed using Google sensing, because cloud is a big problem for optical remote sensing. And throughout the year, you in some locations you really have a cloud-free imagery. And then with just a couple lines of code, you can create cloud-free. You can also create time series cloud-free images by utilizing the cloud computing power to process images by pixel. And then you can get the base quality pixel. When you put all the pixels together, then you become a cloud-free imagery. And so Google Sensing has a big data catalog. It's over 100 petabyte right now, and it's continuing to grow. So it has tons of data. Most data in the public domain already has that. So if you already use Google Sensing, the JavaScript API, you might have used some of those data. So all you need is to go to the website, source the data, and then you can just import the data into your catalog. So just pointing to the data, you don't have to download anything. And so right now we have Landsec 8 and 9 running, and we are going to have Landsec next in 2030, in 5-6 years from now. And so the resolution is going to increase from 30 meter to 10 meter, and also the spectral band is going to increase from 11 to 26. So the file size is going to increase from 1 to 20 gigabyte. And so right now you're still using some desktop computing, you have not used cloud computing yet. It might be okay if you're doing for a small area, but in couple years, when Landsec Next is launched, you will not be able to process the data, because one image thing going to be, for example, the same size is going to be 20 gigabytes. So it's going to be much larger. And even if you have data storage, the computing power is going to be very intensive. You're going to try to process, for example, just a small area with 20 gigabyte data. So just to keep it in mind, you need to prepare yourself for the next generation of satellite data. And so this is where GEEMap comes in. It built on top of Google Sensing. So before we get into that, I would like to point out the differences between the JavaScript API and also the Python API. So if you already use the JavaScript API, you might have know some of these advantages. So the JavaScript API has a lot of documentations. So when Google Sensing was launched, I started using it in 2016, 2017. Most of the documentation were using JavaScript. Not many examples for the Python API. And it's interactive. It's built-in authentication, so you just need to log into your account using the browser. You also have the Google Sensing app that you can deploy to create web apps that can share with other people that don't have a Google Sensing account. The downside is that you cannot install any additional packages. You're limited to the browser, and you cannot upload data directly to the code editor. To use in the code, you need to ingest into your Google Sensing account before you can actually use the data. And also, there's not really communication with your computer. You cannot use IDE. You only can use the Google Sensing code editor to write code, and the debugging and also the code auto completion is quite limited. So the Python API is more flexible, although it has less documentation. Now it's getting a lot better. It's improved a lot during the last year or two, but you can use a lot more options available for you to use. You can use more IDE, for example, you can use Visual Studio Code, you can use PyCharm, Jupyter Lab. You can also integrate with Desktop.js, QGIS, ArcGIS. You can directly access those cloud computing, and you have a lot more packages available that can do interactive mapping and also plotting. You can also do deep learning. So that's one of advantage of using Python, is that there are lots of deep learning library available that makes it easier for you to run deep learning algorithms on Google Sensing data. JavaScript is not very convenient. So these are some of the advantages of using Google Sensing. So this just shows you the interface. If you use JavaScript, you are already familiar. Like you can write code here, and then you can visualize the data interactively, and you can also inspect the result, and then you can show it on the right. So the Python API mostly just for computation. It doesn't really have visualization functionality. So GEEMap built on top of the mapping libraries, for example, Folium, IPyLibdet, and also utilizing IPyWidget to create interactive widget that allows you to visualize data interactively, and also can change things interactively. And it's open source, so you're welcome to check out the link. If you know how to do coding, you are welcome to contribute to the project. So all the source code is freely and available. And Also, we have a website, GEEMap.org, that has a lot of documentation that you can learn if you want to. It shows you how to install the packages and how to run the notebooks. So right now we have, I think, over almost 140 notebooks available that allow you to learn the package. And also publish a short paper describing what GEEMap is about. So it's about 4 years old now. Uh, I created it after the pandemic, and so far it has been used by a lot of people around the globe, and we have created a lot of novel examples, 141 right now, and I have talked a lot about workshops and conferences and at universities, and so it has over 4 million downloads so far, and thanks to NASA for supporting the GMAP project for 2 years. And so during the last 2 years, we have added a lot of new features and improvement to the package. So GMAP was among one of the some of the popular Python packages that being supported by NASA. And I also published a book last summer. You can check out the book here, the link upper right corner here. All the source code and also all the notebook examples are freely accessible. And if you want to purchase the hard copy, you can check out the link on the publisher website. And I'll show you later how to access some of those resources. So those are kind of the introduction to GMAP. Next, I want to show you some of the key features, like just to give you an impression about what GMAP can do. If you already use JavaScript, perfect. But GMAP can make a lot of things easier, just with a couple lines of code. And so GMAP has been officially adopted by the Google and the Earth Engine team. So now if you go to the Google Engine documentation, they usually, for each example, they have the JavaScript and also have the Python example. So the Python example is actually using GMAP right now. But GMAP right now you can see has a core component and also extra functionality. So the GMAP, the core is officially supported by Google. So it has some features. It's a limited subset of the GMAP functionality, but it's more stable. So because it's supported by Google, but for regular users, you can just import GMAP and then everything else remain the same. You don't have to do this. But GMAP core basically is just a sub module of GMAP that the functionality being supported by Google. And so next, I'm going to show you some core features. So this feature basically means that they are supported by the Earth Engine team. So it's more stable. And for example, base map selector, you can just one click, and then you can change base map interactively with coding. And this is not something you can do using the JavaScript code editor, because you are limited to using the Google Engine base map. You cannot use other base map. But Python is a lot more flexible, so you can use hundreds of base maps or even your own base map if you have a web map service. And besides the base map selector, we can take base map manager, editor, something like that. So on the right here shows you basically the sample. So you can import the GMap core and then just create a map. Then you can point to some data, how you're going to visualize that, and then just map.add layer and then display the map. So this is just a simple example. So in between, you can do a lot of things. What you want to do is create a map and then display the map. And then in between, you can write very complicated algorithms to do a lot of computing. And layer manager that allows you to add multiple data layers, and you can turn layer on and off. So this provides very similar experiences to the JavaScript code editor, allow you to turn layer on and off, and also change the opacity. You can also change the visualization interactively. So for example, you can add a raster data layer and then just select a color map easily. For single band raster, for multi-band, you can also change the band combination easy. So for example, from first color composite to natural color composite or RGB, whatever band combination you want. You can also do vector visualization. So this one shows you, for example, a feature collection, and then you can just with couple click, you can just change the visualization easily, and then you can also click the import button to get the source code, and then you can put it into your source code to reproduce the output without having to use the interface. You can also do inspector, so similar to JavaScript. There you can click and then you can get any vector and raster pixel values and also vector attributes. So very easy to do without having to do a lot of coding. And Also, we support the dual control. So that means you can use the dual control to create Earth engine feature collection, and then you can use that to do clipping or whatever you want. So it's very, very flexible. So all the code features trying to provide similar functionality to the JavaScript code editor. That if you already are familiar with JavaScript, you might find also the GEEMap core functionality very easy to use because they are very, very similar. So those are the core functionalities, and GEEMap has a lot more extra functionalities. As I mentioned earlier, it has over 140 notebooks. So each notebook introduce one or two new features of GEEMap. So this probably shows you on less than 5% of what GEEMap can do. But those are some of the highlighting features that people find it very useful. And similar, here they just show you the example. You can create a map and then just point to the data and then just add that, the same thing. Rather than import GEEMap core, you just import GEEMap. So and then you can have the full functionality. So the first one here is the converting Earth Engine JavaScript to Python automatically. If you have any JavaScript example, you can just copy and then paste, and then just one button, it will help you convert to Python. And of course, it's not 100% perfect. Sometimes you might need to do some modification, but most of the examples from the Earth Engine documentation, you can just copy and paste. You will be able to convert it automatically. So as you can see here, just one button, then you can even if the Earth Engine documentation doesn't provide the Python examples, as long as it has the JavaScript, you can convert it automatically. So this one is allows you to source data. So you can source by any keyword, and then you can select from the drop-down list and just one click, import the button, click the import button, and then you will generate the source code, the example, basically converting from the JavaScript examples to Python, and then allows you to load the data interactively. So as you can see here, you can source any data. So it has over 100 petabytes of data. So all you need to search, and similar to JavaScript, you can just load the data interactively without having to do coding. So this makes it really easy for people that are not familiar with cloud computing, but you just want to type some data, source some data. All you need is just create a map, just 2 lines of code, and then just click one button, and then you can source data, and then you can load the data. Kind of like you can source the movie on Netflix and or YouTube, and then just click, and then just play the video. It's kind of like that, but it's doing that for geospatial. So you can basically load any geospatial data easily using the browser and within GEEMap. And you can also create color bars. So if you're trying to create some visualization, and you can create a color bar, just one line of code. So it can be vegetation data, it can be elevation, it can be temperature, it can be anything, one line of code. So this something might be quite challenging to do using JavaScript. You might need to write a lot of lines of code, but in GEEMap is one line of code. You can also do plotting, so you can create spectral signature, for example, like this without coding. So only just load some data, and then just one button, then you can create this kind of spectral signature easy. You can do also hyperspectral. So if you have a lot of spectral bands, you can also do that easily. And you can customize the plotting. So again, no coding, just load data. That's it. You can visualize time series. So if you have, for example, this is the vegetation, daily vegetation, and you're trying to visualize the data layer. So what we need is just a time series collection, and then just one line of code, you can create this kind of animation. So in that way, you don't have to load all the individual layers. All you need is just one image collection, and then just add one line of code. Then you can visualize that easy without having to add a lot of data layers to the map. You can also get a so-called time series inspector. So you have two image collection that you want to compare data side by side. Again, this is just one line of code to create something like this without having to write many lines of code. And you can do it for use length cover. You can do it for temperature. You can do it for any image collection. You can also have a satellite image collection on the left, the other one on the right. So it's very, very flexible. And you can create, for example, global length cover data set and do some comparison like this very easily just with a couple lines of code. So GEEMap has some functionality that allows you to create length cover, for example, using the dynamic world data set easily. And you can then use some of those visualization tools to quickly compare the data set for different data types. You can also integrate GEEMap with ArcGIS. So all you need is to install the package in ArcGIS Pi environment, and then whatever data layer that you load on the Jupyter Notebook, it will be added to the ArcGIS Pro data layers. So in that way, you can use Google's engine for cloud computing, and once you generate the results, it will be added the layer to the map. So then you can use ArcGIS to create maps, because GEEMap and all Google's engine not for creating fancy maps. It's mostly for cloud computing. But if you want to enjoy the benefit of both desktop and cloud, this might be useful for you. Also, you can use QGIS. There's also a Ghost Engine QGIS plugin, also allows you to access the data layer, Ghost Engine data layer in QGIS. You can also create maps with custom projections. So if you are interested in generating some maps for your publications, you can also do that. This you need to write a couple lines code, but it's doable. So you are welcome to check out the noble examples and then try to customize your own data, and then you can create these kind of projections for depends on the location and the area. You can create it if you want to. So without using desktop.js to create those maps. And you can also create time-lapse directly within the GEEMap interface. So at the beginning, I show you the interactive web app that you can use to create apps. But GEEMap also has the built-in functionality. So you can just one click, and then you can generate the animation for any location. The nice thing about this is that the animation is overlay on top of the base map. So you can actually zoom in and zoom in to any location, and then the animation also will be overlay on top. So you can also zoom in and zoom out directly on the map. So in that way, you can overlay on top of this, and then you can compare different data layers. Again, this is also no coding, but you can just create a map, and then you can zoom to any location. Then you can start doing creating those animations. Last one, if you are interested in sharing your stuff with other people, so you can also create web apps using GEEMap and then deploy in the cloud. So this just shows you an example. So everything in doing here is free. So you can just use the template, and then you can just create a web app and then deploy. So you can share the link with anyone that want to access your web app, and they don't have to have a Google Engine account. This is similar to the Earth Engine JavaScript web app that you create, and then you can share with other people. So in that way, people don't need to know coding. They can use your web app to create something like this. So those are some of the key features I want to show you. Of course, there are a lot more features available, so you're welcome to check out the website. So next, I'm going to show you some additional resources. You can check out this Open Geospatial GitHub organization that I created. And so it hosted a lot of packages that I created. GEEMap is just one of those. So I also have DeepMap, Geospatial, and Segment Geospatial. So you're welcome to try out some other packages that you might find interesting. So the packages basically allows you to do visualization and also analytics. I also created a lot of data catalogs. So not just for Google Engine, but also there are a lot of data from NASA, from Microsoft, and also from AWS. So this data catalog makes it easy for you to actually see what data are available. So you can also develop tools that to access this data, visualize the data, and also analyze the data. And lastly, I have some web apps template. So on the right here shows you web's template created using, for example, Streamlit, Solara, or Voila. So there are different ways you can make your things accessible to the public. And so what you want to do is to depend on what you want. You can use one of those template, and then you can just customize it with your own data. And so I also have a YouTube channel that I posted a lot of tutorials on Google Engine, GEEMap, LeafMap, or database, all kind of open geospatial stuff. So if you're interested in, you're welcome to check out the YouTube channel for more video tutorials. So there's a couple like workshops that I taught in the past that if you want to learn more about GEEMap, I recommend you try it out. So this is the workshop that I taught last year at SciPy. So it has a 3 hours workshop, and I also taught at Google the last year for good last October, and it also has, I think, 3 hours of workshops. So you're welcome to try out this series of workshops. So these are pretty good quality that recorded by Google, and then with some video editing. And the last one here, the latest one, is the one that I talked last week. So it's only a couple of days ago at the Indiana GS conference. So this one is 5 hours. So give you a comprehensive introduction to Google Staging and GEEMap, and it has a lot of practical examples. So also the notebook, so you can check out the video and then learn some of the key features using GEEMap. Get your hands on, and then so they can not just. So most of the features that I showed you earlier is covered in the notebook. So you pretty much learn everything that the key features that you want to learn about GEEMap. And so that's what I want to show you. So next, let me head over to GEEMap. I want to show you some resources here. So if you go to GEEMap.org, head over to the website, and you should be able to find the documentation here. And as I mentioned, you can check out the notebook here on the left side. So right now it has over 141 notebooks. And you can also look at some of the workshops that I taught in the past. There are a lot of workshops. So for each one, you're going to find the notebook example in here. And these are pretty long notebooks. So for example, the one I mentioned, this one was just last week, 5 hours. So you get to a lot of examples that you can use, and you can just change it to your own area. And so if you're someone that you can also do the search. For example, you can just, for example, lens set time lapse. So if you want to create time lapse, you can use this search function, and then you'll be able to see all the source code available. Then you can learn it if you want to. So all the source code is available directly from the search. And you can try out, for example, click the tutorials. So this one also shows you all the notebooks examples in a list. So if you want to search on the page to find some examples, you can do that as well. Last one, the book. So if you're interested in learning more systematic way, then you can check out this book. All the source code are free and open access. If you want to buy the hard copy, you can check out the publisher website. So each one here, you can see the table of contents. So we have 11 chapters. I think total like almost 400 pages. So you can check out the source code here. You can navigate each section, and then you can check out the book content. So the first one has text source code. For other chapters, only have the source code. So if you want to see the images, the figures, and also text, you need to go to the publisher website to purchase a copy. But all you need to do is just to go here, and then you can go to the GitHub website, or you can open it directly using Google Colab. So for example, here you can click open Google Colab, and then you can just start running through the source code because GEEMap has been pre-installed in Google Colab, so you don't have to install it. All you need is just click run, then you should be able to utilize it directly. Of course, you need to authenticate your Google Staging and also initialize, but you don't have to install. You see, I just import it. I don't need to do anything. So you can just import the library. That's it, and you need to authenticate your account to be able to use that. But it makes it really accessible, so users don't have to install packages on the account anymore. They can just run the code and then you can test it. You can also go to the GitHub. So here, if you go to the repository, you'll be able to get access to all the source code available. So you're welcome to ask questions here. If you have any questions about the books, and all the source code is under the notebook in here. So all the notebooks and also the markdown. So if you're someone that want to get all the source code all at once, then you can go to my GitHub repository to download all the source code. And so all you need to just run through the examples and then try it out. And I welcome your feedback. So these are some of the additional resources I want to show you if you want to learn more. Again, it's for today's presentation, I cover some of those, but not everything. So you're welcome to check out the notebook to see more details about GEEMap. Okay, so that's all I want to share with you. I'm happy to take any questions.
Okay, so thank you very much, Qiusheng, for this session. That was really great, and we do appreciate. In fact, what we wanted to mention to our members is that is that you approved our request to have this book published in our site, and this was a great opportunity for our members to have access to this book. So what I'm going to do is just to share the link to our website in the chat, so that anybody who could have missed could also access the book to that through the community website. Meanwhile, we could have the questions from the members. If I could see some of us have questions, have raised their hands, so we can just get started by having Marvin, please. Maybe you can just open up your mic and go on with your question. Yes, Marvin, please.
Yeah,
Okay.
can unmute. Yeah.
Hemika,
Hello.
Yes.
I want, yeah, hello. I wanted to ask about multiple buffering.
About what?
Hello.
Uh, we lost you.
okay. Maybe you can type on the chat. Then we have Hemika, please.
Yeah, hello. Can you hear me?
Yes.
Yes.
Yes. Hi, Doctor. Thank you for this lecture, and thank you for the community of GEEMap that you've been pushing. I've been following most of your work. I did one of your course with United States University. Was this Water University of UN University, basically, and I've been following your work on YouTube. So I don't know. I want to know, in case we are having issues when we are using the GEEMap. For example, I was working on a research recently on drought analysis. I was trying to work on vegetation condition index. So I was using the GEEMap zonal statistics by group, but I noticed it wasn't giving me the number of classes that I have on the raster. So after converting it to FC, which converts it to a shapefile, a vector, or a feature class, I noticed the number of classes that I have, because when I reclass the raster image from 100 to 6 classes. So on converting it using the zonal statistic, I was getting just 4 classes. So in this kind of issue, is there a place where a community where we can drop this kind of question? Just because I've been working on it for over a week now.
Yeah. So here, I recommend you just go to GitHub, go to the website, and then click on the GitHub. And there's a discussion board here. If you click the discussion, here's where people ask questions. You will see I answer questions every day. So if you have questions, you can post a question here, and then also provide some sample codes, and then we'll be able to help you out and provide examples. So specifically for the question that you're asking about the zonal statistics,
yes.
you can go here, for example, zonal statistics, right? So here's the
by group.
I think let me source the source this zonal statistics by groups here. So you can look at the source code. I think what you need to do is to specify the scale. By default, it's none. I think.
Yes.
Look at it. Just specify this one. By default, is probably 10 times of the scale.
Yes.
So it's like coarse resolution. So sometimes we resample and then skip some of the smaller classes. But if you want very detailed, then for example, you're using lens, you can specify 30 meter, whatever resolution that you need. But keep in mind, the larger the number, the higher the resolution, the more likely you're going to run into memory issues. But if you just need a rough estimate, you can keep this one as none. But if you want very accurate, then you specify a number, but you might run into memory issues when you specify a small number for large area.
Okay. So I'll just drop the question, because what I was using was the Modis vegetation 1
then you
kilometer,
say to 1,000.
16 days. Yes, so I set the scale to 1000. I wasn't trying to download it. What I was just trying to do was to convert it into a data frame so I could get like a graph just to show trends by states. Yes, maybe I'll
Yeah,
just
change to
drop the question
1000
and drop
and
my
give
code.
it a try.
Yes, I did it to 1000. I think I'm not really sure because I know I specified the scale, I specified the region, that's the region of interest, so that I specified everything. So I wasn't really sure how it would have been. But thank you. I'll check the GitHub, or if possible, I can share my code. I don't know.
Sure, yeah, just ask a question on GitHub, then we can help you from there.
Okay. Okay. Thank you very much, and thank you for your work.
No problem. Next one.
Yeah, Ilana, please. So I can go on to Irene.
No, can you hear me?
Yes.
Yes.
Yeah, thank you for the presentation. It was really amazing and really great. Thank you. Actually, it's really very interesting work. I just have two questions. The first, like it's like this platform.
We lost you. Or is it just me?
No,
Not
it's not
really.
just you.
I
Yeah, I
think
cannot
it's
hear
just
anything.
okay. While she comes back, we can have Irene, please.
Hello, good evening. Thank you for the presentation. My question was brief. I've been trying to initialize the Art Engine library on my Jupyter notebook, even after authorizing it by inputting the code that is being redirected. I wasn't able to run like it. I got stuck there. It's not
So
working.
just
So I
like I
don't know.
mentioned, ask on the GitHub discussions. You can post question there. It might be your account problem. It might be how you set it up. So just provide the screenshot and the source code that you use to authentication. We can help you from there. Right now, I cannot see, so I don't know what exactly the problem is.
Okay. Should I share my screen?
Yeah, if you want to, it's up to you.
All right. This is where I got stuck. I don't know if you're able to see my screen. This is where I got stuck. I couldn't run this code from here.
What do you mean? So it's already authenticated. Do you run again? So run that code block.
Sorry?
Yeah, do you run it? I don't see you run it.
Okay.
So authentication is only one time only. You don't need to authenticate all the time. It's just one time only.
But it's not picking on the second code. That was my
What do you
issue.
mean not picking on the second call?
After initializing and authorizing with the code, nothing's happening from here.
Oh, you need to click and then join the authenticate. Just
Yes.
uncheck the E authenticate. You don't need to run it all the time. It's authentication is only one time only. You don't need to initialize for every notebook.
Okay.
And you cannot just use e.feature collection and then just pass in your local file pass as share file. You need to use GEEMap.
That's okay. That's okay.
So
I
basically,
will
go to
try.
the GEEMap website, check out some of the notebooks. Basically, your source code is incorrect.
Okay.
So go to the Google Engine, the GEEMap website, try out some of those notebooks. You can try out in Google Colab directly. This is not really a GEEMap problem. It's more like how your source code problem.
Okay. I'll try on my own time then. I will try reach out for help.
Okay.
All right. Thank you.
Okay. So we can have Elana, please. Oh, Dennis, let's go on.
Hi, Prof. It's a really good pleasure to have you here. I'm a student as well, following along your YouTube channel on the UTK website. Really
Okay,
cool
thank you.
stuff, the things you do on the summer. Two questions. One, how would you suggest we handle proprietary data, and especially specifically data points or surveys that would be covering personally identifiable information for like points or whatever, while trying to build this up? What would be like just your general suggestions and offers, and maybe the second question would be, is it possible to just send you my mock project that I'm using following along your lectures at the UTK GE Geographic Software Development course that you're offering as well?
What's the second question again? Saying what?
Is it? Are you open to maybe take a peek at my project that I'm doing, following on your lectures for the UTK course that you are working on? I know it's like a course that you're doing with your students and everything, but the
Yeah, you
lectures
can
are
share on the GitHub. So there's the course website. You can, if you have something to share, you can share on the GitHub website. If you want to share like the project that you created, yeah, you can share on GEEMap website, also on the software design GitHub website. There's a GitHub discussions that you can share whatever you want to share with other people.
Okay, cool. Thanks.
And for this first question about some private personal data, you can just upload to your Google Sensing co-editor, and by default it's private. So as long as you don't share with anyone, then the data stay within your account. And certainly, I mean, nowadays, nothing is really private. Nothing is really 1%. As long as you use cloud. So just like you upload things to your Google Drive, it stay within your Google Drive. If you don't share with other people, then it's yours. But I mean, Google knows a lot about you. So even if you don't share with other people, they might know the data. So it's up to you what you want to, whether or not you want to trust those big tech. If you trust them, then you can upload data, and then as long as you don't share with other people, it's yours. Then you can use that within your Google Sensing algorithm development in your source code. You can import the feature collection or the image collection or the images that you want. If you don't trust the big tech, then you do it locally. Then you use desktop computing. You use the whatever Python packages that you want to use. For example, you can use GEEMap to do visualization, do some analytics. But the downside is that you cannot really utilize the cloud computing power and those API provided by Google, by Microsoft, or any other services. So there's probably pros and cons. So it's up to you what you want to do. But at least you can upload to your account, and then the data is yours. It's up to you whether you want to trust Google or not. Did I answer your question?
Yeah, that makes sense. And I have an anonymization protocol which does like generalize or shifts coordinates and stuff like that for point data, at least by a few, especially for household information. And this is for data for Somalia or really challenging locations that might prove like as a security issue to like
It's the
respondents to
same
serve.
thing. So to me, it doesn't matter. It's Google or people upload data to ArcGIS online. It's the same thing,
Yeah.
right? Do you want to trust them, or you create some web app that, as long as you upload data to the cloud provider knows your data. They might encrypt the data, whatever, but your data is somewhere. So, and you need to make sure that if you want to share with other people, the data doesn't contain the sensitive information to expose people's information online. Okay, next questions. Any other questions?
Okay, so thank you for that. I think if we do not have another question, I can also go on. So I also wanted to understand, though, like, is there a way in which somebody can initiate a Google attention the Python API such that it picks data as being updated from the Earth Engine catalog, such that if we are monitoring maybe something which is changing over the time, probably like 1 month, next month, like month, an automated way in which you can be able to monitor a change in a real-time manner. Is it possible to have that implemented with the GEEMap API?
Yeah, you can. So in your source code, all you need to just, for example, they say you are monitoring forest change using Lancet data. So in your source code, when you're doing the filtering, for example, you can use Lancet to GEEMap to create, a monthly composite. And what you need to just set the end date to be something far away, for example, next year. Then whenever people go to a web app, when they click, it's going to run the code from the beginning. So if you already set our algorithm to access the data from the next year, then people are going to get the latest imagery. So just don't hard code it the date in your source code to be something like in the past. So for example, if I'm writing the algorithm like today and then trying to do the mapping, and then you're trying to use GEEMap for example, create the imagery by year, for example, or for the summer, right? So I can write the start date is January 1st. The end date, you don't write the end date today. You don't write May 23rd. You might write December 31st, 2024, right? So when people open your web app, it's going to run a source code. Then whatever date, for example, if they open next month, then the end date will still be something far away. So you're still going to get the latest imagery. So it's up to you how you want to do that. But certainly, web app can retrieve data on the fly. So whatever data available from the Earth Engine data catalog, you can get it. And the other way, if you want, you can also monitor the GitHub Earth Engine data catalog. So if you go to, for example, my GitHub, so Open Geospatial Solutions here, I have a repo called Earth Engine Catalog. So this one actually has all the data available. So you can see actually, if you want to monitor, you can see this is automatic running every 24 hours. And you can see what data set have been updated. So for example, here, there are tons of data set. For example, 139 data set has been updated, right? So if you can see Copernicus, let's look at, for example, Lancet, right? Lancet 9 here, collection 2. You better find out, for example, what's the latest one, what's the latest imagery have been updated. You can see from April 1st to April 2nd, right? May 17 to 18. So all the images that have been updated is actually being recorded here. So if you want to see that every day, for example, every hour, you can also follow this GitHub. So this is running automatically every day just to get the latest one. So you can certainly, this is one way you want to do that, but in general, you just need in your Google Sensing source code, you just do that. So here you'll be able to see, for example, the TSV, right? All the data set, start date and the end date, right? So this column going to change depends on whatever the latest one, right? So if you go to, for example, let me look at, how about Lancet, right? Lancet here, Lancet 9, whatever. So if you scroll to the right, you will see this column is being updated, right? So 2013, and this is 2014, May, for example, 22nd, right? So it's only yesterday. So it's going to keep updating. You can actually monitor this TSV if this is something you want to do. But the better way will be in your source code. You just don't hard code it the end date. You hard code it the end date to something a year later, or get the latest date. For in Python, you can always use package, for example, the time to get the current date of right now, and then you can get that date passing to the source code. So in that way, the date is always updated, depends on when the user opened the web app. Does that make sense?
Yes, that really makes sense. It's nice. Yeah. So welcome Anybody with any question before we close? Because now it's 4 minutes past. Okay, maybe Joseph, please.
Hello, thank you for the nice presentation. Actually, mine is just a comment. I like your work and I like what you are doing. Thank you for contributing to the open source community. Thank you.
Thank you very much for your feedback.
So before we close, I can see Mokaria here is raising hand. Maybe you can speak.
Hi, Professor.
Yes.
Okay, thank you. Thank you very much for your presentation. So I have a question about crop typing. So, for example, we have an asset, a data collection made in Senegal. So first, it is a point, but we have some big challenge to come to make the crop type over this point. We go on digitize polygon of this point. Now we have a kind of other problem which is overlap. Like we have many points in the same plot. We make digitize. Now we are looking for to get a kind of accuracy with this polygon to come to solve the problem of overlap. So we now the problem comes from first about the dates to get the imagery high resolution. Example, working on Google Earth, we don't have the same period that we get the data. We don't have this image from Google Earth for high resolution. So to get the image at the moment that people collect the data to be ready or to be to get a kind of base map which can allow us to say that in this plot we are able to see that there are difference between 2 points. First, for example, if we have 2 points in the same plot, we can be able to know that the first one is the first crop and the second one is the other crop. So now, Prof, what we come to see that GEEMap can allow us to get big possibility to do a kind of machine learning. What kind of issue or solution GEEMap can bring us to overcome of this problem that we have and the rest of the process for the crop type. Over.
So this is something that not necessarily you need to GEEMap. If you only have a couple points, and for the crop types, I'm not sure if you're using Google Earth or Google Sensing. Are you already using Google Sensing or just Google Earth?
We are working on two Google Earth Engine and Colab.
Yeah, if it's Google Sensing, then you can access those Sentinel next images. So it depends on what data you have. You can just filter the data to select the data, whatever you want. And Google Sensing already has machine learning, deep learning capabilities. So you can go to the documentation website and then you can find examples from there. All you need to do is just figure out what you want, and then filter to get the data that you need, and then you can run algorithms. You can use GEEMap to do the visualizations, but all the computing come from the Google Sensing API. So you need to use the whatever Google Sensing supports, and then you can build the algorithms on your own.
Okay, thank you.
Okay, so thank you for that. We are now going to close the meeting. And what I wanted to share with you our Google Thinking Developer Community Nairobi website, which have already shared in the chat. And this was really great, highly supported by most of Google Thinking developer experts who have highly been of great support, and we do appreciate Dr. Qiusheng because he has also offered his book with us so that everyone can get to learn in our community. So you can find the resources in our website. It is so I'm just posting it here in the chat. So anyone who has not access, you can just click see all the resources that we have and all other community details in case you have something you would want to communicate to us or you would love to share with us. We are open for presentation also within in-house because we have had opportunities to learn from experts outside, and we are also open to learn from within the community. So we do appreciate so much, Prof, for having time with us, and this was really, really so kind of you. In this meantime, I would love to just mention our team here. We have Joseph. Joseph is a GIS specialist, and Christopher, who is also a GeoGuba thinking developer and also a data engineer. And Michael Wafula here is another GIS developer. So, but we can just give an opportunity to Michael, share comments before we close the meeting. Michael, please.
Oh, yes. Thank you so much, Nick, for the opportunity. Thank you so much, Prof, for the nice and insightful presentation. I think it has been one of the best one, and I personally have learned a lot, and I hope we'll be able to, probably in case of any challenge, we can always reach out because you have provided almost like all your contacts so that we can be able to reach out to you on GitHub. Yeah, so mine actually was just a comment. Thank you so much for the presentation, and thank you.
Okay, thank you everyone for attending. Again, if you have questions, feel free to go on the GEEMap GitHub discussions. And take care, everyone. Thank you.
Thank you. Thank you. Thanks so much.
Thanks, everyone.
Thank you very much.
Bye.
Bye-bye.
Hi.